Isolated ground receptacles are designed to reduce electrical noise in sensitive circuits, but they must be grounded correctly to ensure safety. Connecting the terminals of isolated ground receptacles to a ground rod, without any connection to the building's equipment grounding conductor or grounding electrode conductor, creates a dangerous situation. This practice will not operate in an overcurrent protection device, such as a circuit breaker or fuse, if the item plugged into the isolated ground outlet falls to ground. Such a setup introduces several hazards, including electrical shock, fire, and reduced overcurrent protection. Firstly, electrical shock hazard. Without a proper connection to the grounding system, fault currents may flow through a person touching the receptacle or connected equipment, creating a severe electrical shock hazard. Secondly, fire hazard. Fault currents flowing through the ground rod can cause excessive heating and potentially start a fire. Thirdly, reduced overcurrent protection. The overcurrent protection device will not trip in the event of a ground fault if the receptacle terminals are not connected to the building's grounding system. The National Electrical Code, or NEC, and the Occupational Safety and Health Administration, or OSHA, have specific requirements for grounding. The National Electrical Code requires that isolated ground receptacles be grounded to the building's grounding system. The Occupational Safety and Health Administration also requires that electrical installations meet specific grounding requirements. Grounding the isolated ground receptacle terminals to the building's equipment grounding conductor or grounding electrode conductor provides a low resistance path for fault currents. When the item plugged into the isolated ground outlet falls to ground, the fault current will flow through the ground wire, tripping the overcurrent protection device and disconnecting power to the circuit. This is how electrical safety is achieved. Connecting the isolated ground receptacle terminals to earth without connecting them to the building's grounding system provides no safety benefits and violates established codes and standards. Consider a scenario where an appliance connected to an incorrectly grounded isolated ground receptacle experiences a ground fault. If the receptacle is only connected to a ground rod, the fault current will have a difficult time returning to the source. The resistance of the earth is typically too high to allow sufficient current to flow to trip the overcurrent protection device. This means the appliance chassis could become energized, posing a shock hazard. Additionally, the prolonged fault current can cause overheating, increasing the risk of fire. In contrast, when the isolated ground receptacle is properly connected to the building's equipment grounding conductor, the fault current has a low impedance path back to the source. This allows a large amount of current to flow quickly, tripping the overcurrent protection device and energizing the circuit, thereby eliminating the shock and fire hazards. The equipment grounding conductor is a dedicated wire that runs with the circuit conductors and connects the metallic parts of electrical equipment to the grounding system at the service entrance. This creates a safe path for fault currents, ensuring that overcurrent protection devices operate correctly. The grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod, metal water pipe, or ground ring. This provides a connection to the earth, which helps to stabilize voltage and provide an additional path for fault currents. Here's a step-by-step explanation of how proper grounding works. Firstly, a fault occurs. An internal fault occurs in an appliance connected to the isolated ground receptacle, causing a live wire to come into contact with the appliance's metal chassis. Secondly, fault current flow. The fault current flows from the live wire to the appliance chassis and then through the equipment grounding conductor connected to the isolated ground receptacle. Thirdly, low impedance path. The equipment grounding conductor provides a low impedance path for the fault current to return to the source. Fourthly, overcurrent protection device trips. The high fault current causes the overcurrent protection device to trip, disconnecting power to the circuit. Fifthly, safety ensured. The appliance is de-energized, preventing electrical shock and fire hazards. The National Electrical Code provides specific guidelines for grounding isolated ground receptacles. These guidelines are designed to ensure that isolated ground receptacles are installed safely and effectively. Some key NEC requirements include Section 250.96, bonding other enclosures, metal raceways, cable trays, cable armor, cable sheaths, enclosures, and other metal non-current carrying parts that are likely to become energized shall be bonded where required or otherwise connected to an equipment grounding conductor. Section 250.146. Connecting receptacle grounding terminal to the equipment grounding conductor. An isolated equipment grounding conductor as described in 250.146d shall be installed from the receptacle to the equipment grounding conductor terminal of the applicable derived system or service. The isolated equipment grounding conductor shall be identified by one or more stripes or a distinctive marking at the termination points. For effective grounding, it is essential to use the correct type and size of grounding conductors. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. The National Electrical Code provides tables that specify the minimum size of the equipment grounding conductor based on the overcurrent protection device rating. For example, Table 250.122 in the NEC provides guidance on the minimum size of equipment grounding conductors for grounding raceway and equipment. It's also important to ensure that all grounding connections are tight and corrosion-free. Loose or corroded connections can increase resistance, which can impede the flow of fault current and reduce the effectiveness of the grounding system. Regular inspections and maintenance of grounding connections are necessary to ensure their integrity. Isolated ground receptacles are typically identified by an orange triangle on their face. This helps to distinguish them from standard receptacles. They are often used in sensitive electronic equipment installations, such as computer rooms, audio recording studios, and medical facilities where electrical noise can interfere with equipment operation. However, their proper grounding is critical for safety. Installing an isolated ground receptacle incorrectly can negate its intended benefits and create safety hazards. It's important to follow the manufacturer's instructions and the requirements of the National Electrical Code when installing isolated ground receptacles. Proper grounding is not just a matter of compliance with codes and standards. It's a fundamental safety measure that protects people and property from electrical hazards. Understanding the principles of grounding and the requirements of the National Electrical Code is essential for anyone working with electrical systems. In conclusion, grounding isolated ground receptacles to earth without connecting them to the building's grounding system is an unsafe practice that violates electrical codes and standards. It poses a significant electrical shock and fire hazard and negates the intended safety benefits of isolated ground receptacles. Properly grounding the receptacles to the building's equipment grounding conductor or grounding electrode conductor is essential for the safe operation and protection of electrical circuits. Always consult with a qualified electrician if you have any questions or concerns about grounding electrical systems. Electrical safety should always be a top priority. Ignoring proper grounding practices can have serious consequences. Ensure that all electrical work is performed by qualified individuals who understand and adhere to the National Electrical Code and other applicable standards. This will help to prevent electrical accidents and ensure the safety of everyone who uses the electrical system. When discussing these concerns, emphasizing the importance of safety and the dangers associated with improper grounding is crucial. Connecting the isolated ground receptacle terminals to earth without connecting them to the building's grounding system provides no safety benefits and violates established codes and standards. Reference the National Electrical Code and OSHA requirements that mandate proper grounding. Use technical terms and provide examples to support your argument. If necessary, involve a supervisor or qualified electrician to provide additional clarification. By understanding and adhering to these principles, you can help ensure the safety and proper functioning of electrical systems. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or concerns.